Welcome all. Okay, this is a artificial general intelligence series. Okay, so in this video we are going to see how to defining and measuring the intelligence. Okay, how to defining and measuring the intelligence. For defining and measuring the intelligence, they have introduced the abstract reasoning corpus. Okay, abstract reasoning corpus benchmark. We are going to see in detail about this abstract reasoning corpus benchmark and how it is using to defining and measuring the intelligence. And this video is based on the paper on the measure of intelligence. Okay, on the measure of intelligence by Francois Chollet, and this is from the Google, and this is published in 2019. So I will give this download link of this paper in my description. Okay, in this video's description. Okay, now we will see our first slide. Okay, so first they have defined. Okay, they have defined. Okay, so hierarchy model of cognitive abilities. Okay, so what is the cognitive abilities? Okay, so first we will say, oh, first this is the task specific skills. Okay, task specific skills, there is absence of uncertainty and no generalization. Okay, so absence of uncertainty means these kind of systems will run within the range of training data set. Okay, within the range of training data set, we can say within the range of. So if a system running within the range of training data set, we can say this is the task specific skills. Okay, there is no data come beyond this training data set. Okay, it will run perfectly in the training data set. It will give the good results. Okay, there is no absence of uncertainty and there is no generalization. Okay, so next they defined broad cognitive abilities. Okay, broad cognitive abilities, it has a generalization. Okay, it has a generalization. For example, our LLM models. Okay, for our LLM models, so if you take our LLM models, it can do lot of tasks. Okay, it can do lot of tasks. So it has the generalization. So it can check whether the it can check sentiment analysis. It can do sentiment analysis. It can do the question and answer. Okay, it can do the question and answer, and it can summarize a document. Okay, any task. Okay, any task it can do, and it can work beyond it. What is say beyond it training data set. Okay, beyond it training data set, it will give a decent results. Okay, so these kind of systems are, okay, broad cognitive abilities. Okay, and if another system will do these kind of multiple tasks. Okay, this is the LLM. Next one is the, what I say, next one is the one one stock price prediction system, stock price. Okay, stock price prediction system. Another one is the image analysis system. But all are running under some basic general intelligence. Okay, general intelligence. Okay, so intelligence is common. Okay, this is, if you say human can do, okay, all these things. Okay, because we have the one common intelligence. We can do stock price, we can analyze the stock price, and we can forecast the stock price, and we can analyze the image. Okay, we can analyze the image, and we can do the all the LLM jobs. Okay, we can do a sentiment analysis, we can do summarize the document. Okay, summarize the document, and we can do question and answer. So all these things we can do. So this is the general intelligence. Okay, so if a system can do multiple different broad cognitive abilities. Okay, so then it is the general intelligence. Okay, now we are going to get a framework. Okay, get a framework to how efficient this general intelligence. Now we have to get the score. Okay, so this system is 80% efficient. Okay, this is okay, general intelligence of 80%, and another system is 90% of general intelligence. Okay, so if it is 100% means it is almost equal to human. Okay, so this is now we can compare. Okay, so if it is one got 100% general intelligence, then it is equal to human. Okay, now we need, okay, this is a very difficult task. Okay, to define a specification to get this numericals. Okay, get this numerical, how this is efficient. Okay, so already we have the Turner test. Okay, already we have that Turner test. Okay, now what they are saying, Turner test is just, okay, so there's a bias. Okay, there's a past, because human is the judge. Okay, human is the judge to evaluate the system. Okay, now we need a clear cut framework. Okay, now we need a clear cut framework to define a general intelligence of the system. Okay, okay, so next we will see. Okay, this is about this slide. Next slide we will see our next slide. Okay, in our next slide. Okay, in our next slide. Okay, this is our next slide. In this slide, okay, in this slide, so now this is our problem statement. Okay, so our problem statement is the artificial intelligence. Okay, this is a, so this is nothing but, if you see in my deep learning series, in my introduction video, okay, machine can think. Okay, machine can think. So, and I have given different topic. Okay, different. Okay, I have given different topics to define. Okay, different concept. Okay, different concept to define the artificial intelligence. Okay, there is the, so agent environment. Okay, there is the agent environment is the somewhat acceptable, that definition. Okay, this is the agent. Okay, this is the agent. Okay, this is the schematical representation of the artificial intelligence. This is our environment. Okay, this is the environment. So now we have to give the benchmark for this. Okay, this is the environment. This is the environment. Okay, this is the environment. Okay, now we have to give the benchmark for this intelligence system and compare to the human. Okay, this is our ultimate task. Okay, so next, okay, we will see our next video. We will see our next video. uh, next slide. Okay, next slide. Okay, next slide. So first, before we are, okay, but this is a, yeah, approximation. Okay, this is approximation. So before generating a exact number compare with the human intelligence. Okay, exact with the human intelligence, we can say what is lower intelligence. First, this is the approximation. Okay, this is the, what is the lower intelligence. Okay, what is the lower intelligence. Okay, what is the lower intelligence and what is the higher intelligence. Okay, so this is give us the definition of what is a lower intelligence and what is a higher intelligence. Okay, so a lower intelligence system is defined by lower information conversion ratio. Okay, this is a known situation. Okay, this is a known situation. Okay, this is the situation space, known situation. This is the operational area. We will get the lower information conversion. Okay, if the higher intelligence system, higher information, for example, so this is the, yeah, system which will analyze the images. Okay, so if you give the image, so okay, it will say this is sex. Okay, whether the given image is the male or female alone. Okay, this is the given male or female. Okay, so if we give, this is the only one information. If we, another one is give the age. Okay, age and sex, male or female. Okay, male or female, and ethnicity. Okay, and next what is, okay, some other more information. If it is give more other information, so this is the higher information conversion ratio. If it is has a higher information conversion ratio, this is the higher intelligence system. This is the, if you lower information conversion ratio, this is the lower intelligence system. Okay, this way they have defined. Okay, so this is the general approximation. Yeah. So next we will see, so this is the starting point. Okay, before we are defining the exact number, first we will start what is a lower intelligence system, what is a higher intelligence system. Okay, uh, next we will see next. Okay, so already we have seen, so this is the ARC dataset. Okay, so this is the ARC dataset first. Okay, so they what, okay, what will they call, so already how the intelligence system, usually the chess game. Okay, usually the chess game is the one of the benchmark. Okay, one of the benchmark. Okay, if A can beat, okay, A can beat the grandmasters, then that those kind of artificial intelligence systems are, yeah, high efficiency systems. Okay, high efficiency system almost is equal to human knowledge. In this way we have defined. Okay, we have defined, so such a way, but that is, okay, such a way, but there is somewhat not in a what I say, yeah, clarity. Okay, that is, we have to generate numbers. Already we told you now, so we have to generate numbers. So what they have done, they have created a data set, that is the ARC data set. Okay, that is the ARC data set. ARC data set. Okay, ARC data set is the abstract reasoning corpus. Okay, abstract reasoning, okay, corpus. Okay, abstract reasoning corpus. Okay, this abstract reasoning corpus has the 400 training dataset and 400 testing dataset. Okay, so suppose it gives 1000. Okay, so whatever there, there's a lot of, okay, every year they are introducing okay, lot of examples. Okay, training data set. Okay, training examples and training exams. So if our system, in my systems, okay, a human can, or a normal human can solve this system. Okay, the normal human can solve this system. So 80 to, what will they say? Okay, what did they say? So usually 80 to 90%. Okay, 80 to 90% task can solve by a normal human. Yeah, super intelligence, okay, can solve 100%. Okay, 100%. So if it is our program is, okay, if it is our AI program surpass this 80, this is the average. Okay, then it is a very good. Now it is intelligence in the human resembling intelligence, it have the more than the human. Okay, more than the human. Thus this way they have defined this ARC dataset. Okay, so already they have defined, already they have defined, already they have in our second slide we have already seen what is that general. Okay, so we will see our first slide again. First slide. Okay, in our first slide we have seen this is the general intelligence, three intelligence. Okay, broad cognitive abilities and general intelligence and task specific skills. Okay, task specific skills. Okay, this is our, okay, broad, general, broad and task specifics. Okay, so here these all are tasks. Okay, these all are a task. Okay, this is this one task. Okay, three tasks are there. Okay, okay, here we can say three tasks. Okay, this is my task one, this is my task 2, this is my task 3. Okay, this is my task 3. Okay, so by land these tasks I have to produce. Okay, I have to generate the result. Okay, so if I give, okay, this is, okay, if you give these kind of images, okay, this is the symmetrical pattern. Okay, these kind of problems are symmetrical pattern. So if my AI system can solve only this symmetrical, okay, if my AI system can solve this task, okay, if I trained this task, okay, if I train this task, okay, and if I generate the result, okay, generate the result, if it is 100% accuracy, then I can say I am in the last level. This is the task based. Okay, this is the task based. Okay, suppose if in my system, if you introduce another pattern, symmetrical pattern, instead of symmetrical pattern, if you give the filling pattern, okay, if you the filling pattern, it will not work. Okay, it will not work. Some different pattern. Okay, if